Hey everyone, we're back now with page 7 of the AP Chem lecture outline called Gases. Now, there are a lot of teachers out there that make a really spectacularly big deal about the concept of molar volume. And I am going to burst their gas balloon, so to speak, right now. Sorry about that, because it's really not as big a deal as they make it out to be. Now, it turns out, way back, probably the 1940s, and potentially even earlier, students had trouble necessarily remembering the value of R. And somebody came up with a quick memory trick for how to calculate R. And they called it molar volume. For an ideal gas at STP, 1 mole will occupy 22.4 liters. And the number just happened to have a little quirky thing to it the teachers thought students would find easy to remember. 2 and 2 makes 4. Okay? So if you could remember 1 mole at STP was 22.4 liters, you could work backwards and calculate the value of R. Okay? Now we just provide R on all the tests, etc., etc. Okay? So it became somewhat of an easy conversion factor to use, to write it out as 22.4 liters per mole. I have a little bit of an issue with doing that because it only holds at STP, and we really don't often work at STP, okay? So it's not good for much of anything except homework and test questions, okay? Can we prove this to be true? Sure. PV equals nRT, so V equals nRT over P, and we have 1.00 moles, we have 0.0821 liter atmosphere over mole K, we have 273 Kelvin, and 1.00 atmospheres. All right? Moles, atmospheres, and Kelvin cancel, and I got 22.4 liters on my calculator. So it's a memorization tool. That's all it really is. It's a stupid little human trick. Okay? It's not something that you really need to invest a whole lot of time into. Okay? And yeah, we keep silly little things around the room. I've got a beach ball that's 22.4 liters in a cardboard box and that. But in reality, you don't have to, bet the farm on knowing this one thing. It's not probably going to be an AP question. Okay, now, one textbook by an author named Atkins, Atkins is, in my opinion, a really good textbook author. He's done some physical chemistry textbooks, inorganic chem, and general chemistry in addition to science books for the general public. He started to say, it might be better for us to think about it at 25 degrees Celsius in one atmosphere, because we do work under those conditions most of the time. So what would the volume be there? Kind of an adjusted molar volume. So we set it up the same way, and it's still 1.00 moles. And R is R. And this time it's going to be 298 Kelvin to be at that higher temperature. And it's still 1.00 atmospheres because it's STP. Atmospheres, moles, and Kelvin all cancel, and it comes out to be 24.5 liters. And I kind of agreed with that textbook. It's a much more useful tool to do it this way. It just doesn't have quite the interesting little, alliteration of 2, 2 plus 2 equals 4 type thing. Okay? Now, table 7, or question 7, the table. What I did was I wanted to set it up so that you had to do 1 in atmospheres, 1 in torr, 1 in kilopascal. And please do not waste your time converting torr to atmospheres or kilopascal, okay, into atmospheres. I've given you values of R in those other units. Just plug them in instead. Now, if you did okay, 550 Kelvin, no decimal point, 2 sig figs, 0.33 moles, also 2 sig figs because there was no decimal point after the 0 here, 62.0 liters, and since I didn't specify what pressure unit to use, I, of course, am going to run home to atmospheres because it's very convenient and what we're all used to, and I got 5.55 atmospheres. Okay, that's page number 7. Hope you did well on those problems. Okay, Morgan's signing off.